make better decisions and to avoid using this or discourage and trying to do things about using this for creating more misinformation, for deceiving, for doing all kinds of other bad things that.
All right, hi everyone. Welcome to the Actionable ESG Talk series brought to you by AKFI Actionable Knowledge Foundational Institute, the world's first nonprofit industry association committed to bridging the gap between ESG, sustainability, and digital transformation. My name is Isabella. I am the co-host here with Manuel, another co-host, and our special guest today, Tom. Hi, Tom. How are you?
I'm doing fine. Thank you.
Thank you. Thanks so much for taking this valuable time with us, sharing your insights. And Tom is the president of Coughlin Associates and the IEEE 2024 president. It's a widely respected digital storage analyst as well as a business and technology consultant. He has over 20 years in data storage industry with engineering and management positions at several companies, as well as 20 years as a respected consultant. Well, to get it started, Tom, please, given the rapid growth of ChatGPT and all these AI automated software machines and other large language models, what are your insights on the current ESG and sustainability trends, and how do you think they are impacting our storage industry today?
Okay, well, ChatGPT and other types of artificial intelligence involve an awful lot of processing. And they're processing data, and that data is going to be kept somewhere while it's processed, while it's being processed, before it's processed, while it's being processed, and after it's processed. And so that brings into memory and storage, because that's where data lives inside of computers. And so there's the increase in the amount of data that we have that can be analyzed, which many people see as a great business opportunity. Means you're going to have to store more stuff, and not only store stuff in storage, but also it drives the demand for memory, which is where when you're actually processing data, that's where you keep the information you're processing. So an important part, for instance, of NVIDIA GPUs is the high bandwidth memory that they oftentimes have very close to the device itself, and so. Memory and storage, as well as other IT equipment, are critical. Networking as well and processing then are key components in terms of doing AI, and the amount of and so this will require more capital equipment to be able to store and process this data, but it also means that there's more energy consumption used in order to process this information. So I think there's a lot of potential things that could be done with regard to how can we increase the efficiency of these things, of doing AI? And also, what can we do with regard to the lifetime of the products that are being used, the hardware? And then when it's end of life, what can we do in terms of recycling valuable materials that are often included in this hardware? So there's a number of things that so I think that those are elements of digital storage, as well as the processing and networking. And in the storage part of it as well, for instance, if we can recycle storage devices and memory devices, like other technology, generally have a useful life. And if at the end of that useful life we can recycle those materials, for instance, and that's a definite opportunity. So there are IEEE standards that are being developed that relate to this, and one in particular, because it relates to storage, is called P2883 2022, which was created last year, and which involves methods for sanitizing the data inside of storage devices. And there's various ways it can be done, depending on whether it's a hard drive or solid state drive or magnetic tape, for example. But by sanitization, what we mean is removing the data from those storage devices in a way that is understood and that can be certified, And as a consequence, that hardware potentially could be reused. If it's retired from from a data center, for example, if all the user data is off of that content, then it could be reused. Or if it is end of life, or if that's the choice it's made, it could be then disassembled, and components such as a hard disk drive, the neodymium iron magnets, which have an economic value, can be recovered. Standard practice with storage devices in particular in data centers is when they no longer are using them, when they're end of life for the data center, they will burn or incinerate those drives, and that makes it very difficult. For instance, it makes it impossible to reuse them. But it makes it very difficult to try to separate out the materials and recover the elements that went into making those original products. So I think those are some interesting opportunities with one example. And as an IEEE standard, of course, IEEE is one of the largest standards organization in the world. Is responsible for standards governing things like Wi-Fi, the internet, etc. And I think that this is one example of what could become many more standards that relate to sustainability, reuse, and that could be emulated with other types of digital technology, digital transformation technology as well.
Thank you very much, Tom. And just rehash what you said. Incinerating hard disk drives, I assume, produces a lot of toxic waste.
That's true too. Yeah. There's materials in there that when you burn them, they don't make good stuff.
To say the least.
Yeah.
And actually, you gave us a very good image. Is data most of the time lives in one house, in one place. It's taken out, processed a little bit by GPUs or CPUs or like devices, and essentially it's a process of transferring back to memory.
Mm-hmm. Yes.
It's moved from one house to another house, right?
Mm-hmm. Yeah. For instance, you take the data, you train your model, and then you have to store your model so that you can make inference based on that.
Exactly. Then you pick it up again, and you run the inference engine, and then you put it back again, or you put a report out.
Mm-hmm.
So, going a little bit more deeper into the data and the role of data in, or the role of energy being spent on data in data centers.
Mm-hmm.
I imagine there is a large quantity of energy that is allocated to storage. It's not much talked about, however. So do you have some figures, some images for us on how this energy is consumed in data centers?
Sure. Well, over 60% of the energy consumed in servers is either moving data around or in refreshing DRAM. And DRAM is a common working memory that is used in computers. So I think there's enormous opportunities for being able to reduce the energy consumption and improve the efficiency and effectiveness of processing. In particular, if you can process data closer to where it lives, you're not moving it around as much. And there's actually in the storage side, there's an interface called NVMe, Non-Volatile Memory Express, that is being used on a lot of solid-state drives in data centers, and probably eventually will be used in hard disk drives as well. This allows you to do various things. You could do pooling of storage, working on a network, a switch network with the NVMe, and NVMe actually works on the PCIe bus. PCIe bus is a very fast bus in computers. It's doubling with every generation in terms of the transmission rates, and we're currently PCIe 4 is common, PCIe 5 is being implemented, and people are working on PCIe 6. NVMe runs on that protocol, supports it. So if we can, and there's work that's been done in terms of making processors inside of storage devices, like an SSD, for example, that can process special types of data. They call these accelerators or domain-specific processing, or near to storage devices in a network. Now, likewise, also in the memory space, also running on the PCIe bus, there is a fairly somewhat new protocol called CXL. Now, CXL is a switch network for memory, and a lot of memory right now is on a DDR interfaces directly connected to a server. The idea behind CXL, although could be used for expanding the memory on individual servers, can be used to create a pool of memory that in a switch network that can be heterogeneous. That is, they can be different types of memory with different performance characteristics. They can also include domain-specific processors built into this memory bus. So CXL, and again, it runs on PCIe, and so as these generations develop PCIe, we'll have higher performance buses. There's a little bit of extra latency because of that switching network, but it's not much. And so this allows us to, as in the case of storage, now we've got this memory that's pooled. We've got the storage that's pooled. You can also think of pooling processing and pooling networking resources as well, and then using software in order, and they often call this disaggregation of server. We're taking the components of a server, we're disaggregating, we're making pools, and then we use software in order to create software-defined infrastructure. It could be containers, could be virtual machines, things like this that can run processes. And this can be more efficient because it takes data in and out, or it uses the resources more efficiently. We can make better use of them because you can spin them up when you want, and you can spin them down when you want. And so that could be used to make more efficient data centers. Also, if I can use different types of memory, I can put in non-volatile memories. That could reduce the need eventually as the price of these things go down. That could reduce the need for using DRAM, which needs to be refreshed on a regular basis and therefore consumes energy. And combined with these pools and with domain-specific processors or accelerators that could be built into the memory or part of that those networks, we could process data and do some operations a lot closer to where the data lives, so we don't have to move the data around. Those both will reduce the amount of energy. They also reduce the amount of what the CPU has to do. CPUs, because of the slowing down of Moore's law, are not developing their performance as fast as they used to. So that's what's part of what's driving the development of these domain-specific processors, in order to take some functions that the CPU would have to do to take them offline. And if we can do that closer to where the data actually lives, it also reduces that energy consumption. So there's a couple of things that I think that are actually major architectural changes in the way that we build data centers and the way that we do computing that's going to be due to these new ways that we can use memory and storage. And it's all part of this disaggregation of traditional hardware functions, and then being able to manage those and allocate them by the use of software-defined storage or memory, things like that.
Well, Tom, first thing, I want to reinforce for our audience that AI is not as simple as it turning on and off ChatGPT. The second thing, reinforce the fact that memories today, based in today's technologies, are kept powered on all the time. The DRAM requires refreshes, means it stays simplistically said, stays powered on all the time. In our metaphor, the lights are always on in the house where the memory lives, right? Because you have to keep refreshing and
yeah. So if we can reduce that, if we can, and there are developing non-volatile memories that, first of all, so if we've got memory, we've got it on, we want to make efficient use of it, right? So that's what we're doing right now. But long term, there are memories which can approach the performance characteristics of DRAM that are non-volatile, that if the volume goes up, the scale manufacturing goes up, the price could go where they are at the same price or less than DRAM. Those would be even more additional opportunities if we could apply that. Things like magnetic random access memory, resistive random access memory, phase change memory, ferroelectric memory. These technologies could eventually replace some of these volatile memories with non-volatile memories, therefore reducing that need to refresh the charge on them to keep the memory in them all the time, like we have with DRAM.
And going sort of in the more distant future, where Isabella actually is placing her mind, we have also attempts to use biological kind of structures like DNA memory to store large amounts of data. So I think there are even more futuristic views of the memory. But in the interest of time, I would like to switch a little bit the conversation toward the IEEE. Being an electrical engineer, electronic engineer myself, I don't need to ask the question what the organization is. However, for our audience, can you, and as you know, the 2024 upcoming president, can you give us a little bit about the organization and
Sure,
what's important role in the world?
Sure. So it's the largest technical professional organization in the world. In this month, in December of 2023, we have 450,000 members in over 190 countries. These are people involved in every aspect of technology you can think of. We create some of the world's most important create and maintain some of the world's most important standards. For instance, the internet and Wi-Fi are running on IEEE standards. IEEE, with regard to AI, the standards organization also has been since 2015 had a major effort going with regard to ethics and AI and the applications of AI. There was actually a couple of white papers that are available, I think, for free online on a couple generations of a white paper on the design of intelligent and ethical design of intelligent and autonomous systems. And there are a whole series of standards in the IEEE that are relating to what are the ethical uses for AI and how should it be applied, for instance, to human content or for children, things of that sort. And actually that with regard to that, I heard that there's actually a UN rights of the child that was very much influenced by some of these IEEE standards with regard to the children and their interaction with the internet. IEEE is also involved. We have technical societies in almost any technology you can think of. We're responsible for major technology roadmaps that help to guide industry and the development of technology, for instance, in semiconductors, in semiconductor packaging, also in networks, the future of networking, and power electronics. And I'm actually doing one on mass storage. And so we've got a bunch of activities in that area. We've got local sections and we've got 10 regions all over the world, not in outer space yet, that's coming. But, and we've got sections that are part of these regions that have a lot of local activity going on. They have chapters that are often associated with societies or technical councils in the IEEE that are doing local events that are very, very informative, very interesting for people in the area, or since COVID, oftentimes for people who are online to be able to participate and learn stuff. IEEE is a major source of publications. We publish a good percentage of the world's technical literature. We also put on over 2,000 conferences in over 100 countries every year. We've got 1,000 standards roughly, and another 1,000 in development. So we're all over the place. We got all kinds of. If it's technology, that's us.
Well, you mentioned also a subject that I know is dear to me, but is very dear to Isabella, which is ethical AI. Mm-hmm. And somehow, placing it in the center of such large organization, technical organization, is very interesting because we don't know if really ethical AI is, center of AI development. Isabella and I, we have long discussions about it.
So, it fits into it fits into IEEE's mission, though, which is advancing technology for the benefit of humanity.
Mm.
You can see Isabella attention. It's focused on you. So
do you see a better shift when talking about technology back then? Of course, the ethical, it's always part of the concern, but back then, conventionally, technology is more, technical and software engineers. And do you see this shift coming to more a social perspective when developing technology today?
Well, technology can be used for good or ill, right? And it basically is the way in which human beings have figured out how to turn their understanding of the way that the world works, the way the laws of the universe, and applying them. And I think, and IEEE is an advocate that we should be thinking about the implications of technology and how it's used, and and that should be an important characteristic. And I think that it's important for us, especially things like AI, to think about how these are being used and to try to use them in ways that help us to be better at what we must be, versus to harm us or harm the world around us in some way.
And looking out in 2024 in IEEE, how do you see the organization contribute to that part of development to see how the implication is for technology versus developing the technology itself?
Well, so there's another part of IEEE that I didn't talk about. IEEE actually has something called IEEE USA, which is actually although IEEE is based in New Jersey, actually the official headquarters in New York City, but IEEE USA is based in Washington, D.C. IEEE USA is involved in public policy, for example, in the U.S. in particular. And so IEEE and subcommittees in IEEE USA have been, influencing public policymakers, things like the CHIPS Acts, semiconductor development, but also AI and its implementation as well. So, so I think that there's various ways in which we could try to, for instance, influence public policy or inform public policy, at least in terms of what these technologies do, what they don't do, potential side effects of things, and various aspects that may help people make more intelligent decisions with regard to governance or implementation, and recommendations, things of that sort.
Interesting.
Definitely. That's very encouraging as well. It's good to hear that, eventually the largest organization, technical organization that can influence AI, addresses policies, addresses also ethics, not simply, electrons and photons, if I may say that way.
Yeah, and in my own personal view, is that we should not use AI to avoid thinking. AI should be a way in which we look at enhancing who we are, not replacing who we are. That AI should not lead to us dumbing down. I think it's what we should be looking for is that this is a path for us to know more about things around us, to make better decisions, and to avoid using this or discourage and trying to do things about using this for creating more misinformation, for deceiving, for doing all kinds of other bad things. That this is an enormously powerful tool, and it could be used to do a lot of good stuff potentially. But and helping people to accomplish things, but we need to do it in a way that it makes sense in terms of who we are and what we should be.
And hopefully the people that build it will put the right safeguards, at least, so we know when it's misused. And I think that's an invitation for you to come back and we have a whole discussion about safeguards and how IEEE can put those safeguards in AI and make it, as close as possible to have a positive impact on humanity.
Mm-hmm. And you might want to get some other people from the IEEE also involved in that, who are directly working in those areas.
I will love to. So I'll send you an email and maybe you can connect with other people. We had already a discussion on ethics where one of your contributors participated in, Monique is her first name, in some of the early groups on ethics of AI. So definitely looking forward to have a closer cooperation with AKFI, between AKFI and IEEE. Of course, we are small compared to you, so we we can commit only so many resources.
Mhm.
But going actually on AKFI, our mission statement is to bridge the gap between digital transformation and sustainability and ESG. There is a big informational gap. There is a big technological gap because on one hand you have CTOs and CIOs that care about the technology and digital transformation. On the other hand, you have people in sustainability that care about reporting and strategy. So I know actually from a fact we helped Vincola Group with a collaboration on digital transformation and sustainability. So we aware of that. But how do you see it from from your chair? How do
Well, AI, AI is a lot. AI is a lot of different things. So it's not just what a generative AI like ChatGPT uses. It's a lot of other stuff as well. And actually, artificial intelligence could be a very valuable tool in terms of part of that software managing digital resources to make them more efficient, to manage them better, get more done with what you've got, and ultimately, perhaps, to discover new things. That's I look at the good things potentially AI can do is maybe to be an extension of our own brains and our own ability to understand the world around us, and that actually helps us to be better, to learn more, to understand more, to be able to do more, things. So I think there's, like I say, it's a powerful tool. It has a lot of promise. It also has limitations in terms of what it can do. But I think it's being used now, and will be. Things that are called AI are being used now and have been used for quite some time. They're calling them AI now because it's a fad to do that. So, but it's part of our life, and it will be part of our life going forward as well. And there'll be developments and changes in what we can do that hopefully we can again use for beneficial purposes.
definitely we want you back. And also, before we go, I think we have one or more questions. I'll turn it to Isabella.
Younger generation, Tom, I think that's the future, and they show a lot of passion and interest in shaping today's world more than ever. For example, in sustainability, in technology, and artificial intelligence, what's your piece of advice for those who want to pursue a career, let's say, in today's world, combining engineering, sustainability, digital transformation, and ethical AI?
Oh, well, I would recommend they join the AI and help us to create the future. And actually, that's one of my big goals for this next year is that I want to help us be able to retain, engage with our younger members, and have them feel like IEEE is their professional home, that it can provide them the resources, the capability, the networking, and the context that allow them to be successful, and also allow them to make the world a better place, to advance technology for the benefit of humanity.
Thank you very much. And before we go, I say IEEE equals STEM, if I can use a shortcut, because it's a need for engineers and scientists and ethical engineers, ethical scientists, ethical researchers.
Do they have to have technical background to join IEEE, Tom? Or
Well, we've got a lot of different folks in IEEE. We've got lawyers, we've got doctors, we've got physicists, we've got it involves technology, and probably you'd enjoy it, or if you're involved in technology in some way, that's what we're about. So but if you are, then people almost anyone could be part of the IEEE if they wanted to. And we're looking especially for younger folks to do that, because that is our future. We want to develop new leaders and help the next generation to be able to take humankind to where we need to go.
thank you. I like the humanity part of IEEE and of you as Tom.
Thank you very much.
Great recruiting job, Tom. Great thank you.
Awesome. Thank you so much, Tom, for this thoughtful conversation. And thanks to our audience for tuning in today. Make sure to join us every week for a new episode of AKFI Actionable ESG Talk series, where you can gain new perspective on how to mitigate risk and create value by integrating ESG and digital transformation. Until next week, bye for now. Bye, Manuel. Bye, Tom. Thanks so much.
Bye, Tom. Bye,
Bye,
Isabella.
folks. See you later.